Hi everyone, welcome back. So in this video, I will continue with my first video today. In the pre-calculus Math 12, the first lesson is the transformation and the function. And in this video, I will show you how to sketch the function and using the function notation, how the function notation asks us to identify what type of the function we are going to sketch. To make interesting a little bit for my video now, I'm going to show you the student, my student. So here is my student online. He's watching me all the time to check on me to see if I'm doing a good job or not. So it's just fun. Anyway, I'm going to go to show you the function sketching. So bear with me. I'm going to show you. So on the board, I have the on the board, I have the graph. And the question asks us to sketch. Let's say this is the first sketch and this is the second sketch. So it wants us to sketch this function, minus f minus x. Before we doing the sketching of this, we have to realize what is the type of transformation here. Are we sketching the vertical stretch or horizontal stretch or the shift left or right, move up or down? So we have to know the function notation to relate it to what type of function we're going to sketch here. Okay, so let me talk a little bit about the notation of the function. Now, if you register in my course, I will upload on the materials online, and you will have the access to on the beautiful MS PowerPoint presentation, and as well as the practice exercise. You can watch me million times or other professor million times. To be honest with you, if you don't use your pencil, pick up the pen and do it on your own, it's not going to work, right? So you need to practice it. And if you register to my course online, I will have all the information, I will have all the materials for you to register. I mean, like for you to practice. And you will watch my video like this, like very detailed, very information, one-on-one. As I told you, if I'm standing in front of the public in the classroom, I'm teaching the same material. I am a certified high school teacher in BC, and I will just deliver the same material like I'm doing here with my better audience. I just show you. So it doesn't matter. I am the way I am. I am the way how I teach. And you can believe me or not, or you can, like learning the lesson online with me, with other professor, like, but as I said that I'm delivering the same qualify of the content value to you on YouTube or in my course online. And mathematics education is a push in our generation at this period of time, when the industrial world has evolved to the digital world. You need science, you need mathematics, you need technology to catch up with our present time. Advanced technology is changing every single day, update every single day. The only thing you can catch up and try to follow it is the mathematics concept. The mathematics concept never change, never. It can be update, it can be create more and more beautiful, but the core concept, the foundation, has never been changed. And that is why the reason I love math, because I'm just a slow turtle. I cannot catch up with the booming of our technology and advance and thing. And that's why I'm still standing here and teaching you this material. Otherwise, I could do using the mouse and do fabulous on the computer already. But anyway, there's nothing wrong with traditional learning mathematics. And in fact, at some point, and to some certain degree, is a good type of instructional teaching technique that helps, that be able to help all the student and bring them up to the level of foundation. Anyway, let me get back to work. So how do we recognize the notation of the transformation in math? So what kind of transformation look like this when they write like this and they ask us, I want you to sketch this function. So based on the original function y equal f of x, which is this function here. Now we don't know what's the form of this function, like x 3x plus 4 minus 5, whatever. We don't know, and we don't need to know anyway. All what we need is translate this function from this form to this form. And how do we sketch from this form to sketch this form? First, we have to learn the mathematics notation of the function transformation so we can identify what kind of transformation the question wants us to do. Do we want us to enlarge or to compress the function, or to stretch the function, or to move up or down or left or right, like in my first video I was explaining to you. So first we have to learn the notation as well. Now I'm not going to provide you the whole set of notation. Maybe I provide in my papers, on my paper upload to my math courses -online.teachable.com, so that I can persuade you to get into my online course and register for it. If I put everything for free here on the internet, you might not even look at my website, and I'm going to cry about that. It's just kidding, but anyway, because there's a lot of notation, right? So everything have to be written down beautifully to cause attract and make attractive, so that you can look at it and you can remember it better. And that's why the reason. So, but I have to mention to you a few notation here and explain to you, right? Now, any function, you can call it a g of x or f of x or y or whatever. So the notation of the function is f, f of x. Now, when it transforms, it could become, so I put the arrow here. So the original function is f of x. Now, if you put an a in front of it, and you put a f of x here, actually, let me, a of, okay, let's talk about this first, x. Okay. I'm thinking about which way to write down so that you know. Okay. So let's say you have a function f of x. If you put an a in front of it, right? This you call a vertical stretch factor of a. If you put a negative in front of this function minus a, it means you're including the vertical stretch factor and the reflection over the x-axis. Now, if you put the negative inside of the x, then this will include the vertical stretch factor of a, reflection over the x-axis, and this is the reflection over the y-axis if you have a negative in front. Now, further, if you put, let's say this negative outside here, and you have a plus 3. So this will tell you that this function moved to the left unit by 3. Now, this kind of notation you already learned in Math 10 about the transformation of quadratic function. So this is just adding into it. At math language is a sequence of order, and then you adding stuff on the top of it, or more detail and more higher level. And then you go like this, step by step, and eventually you'll be okay. If you jump in the middle, then you fall off, right? And that's why to have the basic foundation and a concept foundation in math is so important for you to move up to the higher level. But anyway, let me talk about this. So I convinced with you that everybody can learn math, as long as you learn in the right way, right? Okay, so this is the reflection on the about the x-axis, and if you have the negative here is the reflection over the y-axis, and if you have plus or subtract here inside the bracket like this, it means you can have a horizontal translation to the left or to the right, depend on a positive or negative side, right? So that is the thing about the notation of the function transformation. Now, let me draw it here. Let's say if you have a set of function. Let's try in general form first, right? So let me put it here for you. So the A factor here is called stretch or compress factor, stress or compress. So stretch or compress depend on the value of the number, right? This will be, and the negative sign here will be reflection over the x-axis. Now, a lot of people say about. I like to use the word over. I don't know why, but anyway, you can say about or over. Usually they use the word about. So the negative here is the reflection over the y-axis, and this sign here, so I'm just calling this is B, this is A, so let's say this is C. This C here is a sheep unit, right? Unit shift. So it could be 2 unit or 3 unit, it's up to the question, right? So you can have a plus or minus here as well. Okay, so if you have a plus sign in front of A, it's noting not reflection over the axis. But if you have a negative, then you have a stretch of A, but also the reflection over the axis, about the axis. If you have the reflection, the negative here, inside the function, then this is reflection about the y-axis. And you also can have a horizontal stretch factor B here, or compressed, right? And the C letter here stands for the unit shape, left side or right side. So this is the general notation of the transformation of the function. Now I'm going to talk about how to identify this right now, right? This function right now. So based on this, you know we have to sketch this original function to change it from the original to the reflection, right? Reflection over the x-axis, because we have a negative here. We also have a reflection over the y-axis as well. So if we sketch, we're going to sketch this original function using this notation, we have to do both reflection. The first reflection is over the x-axis, and the second reflection is over the y-axis. Okay, so let's see what we can do about this. Also, pay attention to the base point, right? Because based on this base point, it's so easy for us to move left or right, up or down, or stretch it, enlarge it, or not, right? So also pay attention to the base point. Is a very good observation and a good strategy to do our work. Okay, so let's see how we can do this. So what is our base point here? I'm going to pay attention to the y-intercept here, right? So we have the y-intercept at 2. We also have the base point here is at x equal 1. And we also have the base point here at x equal 2. So let me mark a few of them. So this is 2 for x and 1 for y. And remember the coordinate always x and y, right? My student always twist y and x, and that doesn't work. So sometimes we have to remember the certain rule in the math notation and the convention of it, right? In physics, we have to know direction up for positive and down for negative. And if we change it, we have to do it inconsistently, right? Okay, so, and that's why we use a common in general so that it's easy for us to remember rather than we twisting it and we don't remember, right? Okay, so this is the y-axis, and this is the x-axis, and I mark this coordinate here and the y-intercept here too. Now, let's do the reflection over the x-axis first, right? And in this notation here, we don't have to worry about factor A, which is stretch factor. Everything would stay the same, except that we're going to reflect this function over the x-axis. So what I do, I'm going to use this base point to reflect it, right? So if my base point here is 2 for the y, then reflection over the x will change the y, right? Reflection on the x-axis will be change the y and not the x. So the output is the same, but we have to change the y coordinate, right? So 2 become -2. So this point will reflect down here, become that point. This point is 1 for y, now reflect -1 for y. You see 1 for y as well will reflect over here. This point is at this level is 3 for y, right? So this is, this is 4 for x and 3 for y. So this point will reflect down here as -3 for y, and the x stay the same, y will become -3. So this point will reflect down here. So this is the first reflection. So let's get the first reflection first. So you see this wrap here will become this wrap when we reflect this over the x-axis. Now, let's do the next one. So now we have to reflect this strap, continue, right? After we do the first reflection here, we have to reflect over the y-axis. Now keep in mind for the stretching or reflection, we don't have to follow the order. You can do the vertical stretch first and then horizontal stretch, or you can do horizontal stretch first and then vertical stretch. But for the for the horizontal shape and translation, sometimes you have to follow the order, and the whole thing should follow the order of transformation. And I will talk about the order of transformation in the lesson plan I upload in my course online, because it will be formal typing on the PowerPoint presentation, right? So in here, I just mentioned to you so that you, I just mentioned to you so you know what it is, not to confuse about that. Now, this is not so hard, but if you combine all the transformation together, stretching, vertical, horizontal, reducing, compressing, and then move up or move down, left, shift left or right, if you all combine on the transformation, it might be difficult topic because plus with the confusion of the sign, right, notation, and that's why students got confused and have a problem with produce a different image, not quite the correct image as the question requires. So make observation, pay attention to the notation of the size, whether it is positive or negative, is extremely important in math, right? So we know this notation is reflection over the axis, and sometimes students don't remember whether or not we reflect over the x or the y as well, right? So that's why if you have right information written down for you and access to my course online, it's important. You will keep track on of this, right? Okay, so negative here is reflection over the x-axis, here reflection over the y-axis. So we do both. Now, for the reflection as well, we don't need to do it in the order. You can do this first and then do this, or you can do this and do that first. Doesn't matter. But here I follow the order. We do the reflection on the x-axis first, and then now we do reflection over the y-axis. So if we do reflection over the y-axis, this one, now when we do reflection over the y-axis, what coordinate will be changed? Do we change coordinate x or do we change coordinate y? Obviously, the y level is not changing, but the x have to be the one you change it, right? So that the coordinate from here can reflect over here. So if you do reflection over the y-axis, you do reflect of the x-coordinate, not the y-coordinate, right? So remember, reflection over the y-axis, right? Reflect, then x is j, but y will stay the same. So the y level here negative stay the same as negative, but the x will become positive 1, become negative 1. So we reflect from here to here. This is the same, so reflect negative 2. So positive 2 become negative 2 for x. Now the 2 for y is not going to change because we reflect over the y-axis, the y stay the same. So this point stay the same. Now this point is 4, so we change to negative 4. So minus 3 minus 4. So I have to erase this. So this go to minus 4 and the y level as minus 3. So that 4 becomes that 4. So now I'm going to draw this graph. So this is the final graph, right? So this is the origin, and this is the first transformation, and this is the second transformation. Now I like to use a different color, but I think that it won't work from the recording of the Zoom recording. So I cannot make this colorful. If I'm good at technology, I can, change this into the red color for you to see. But you got what I mean, right? So this is the first translation, reflection, and this is second. So we're done with the sketching of the first draft. And that's why I mentioned to you the base point are so important when we sketch this. And on the notation important as well, right? Okay, so now let's move on to sketch the second draft here. And what kind of notation is this? So let me sketch the second transformation to the new coordinate grid here, down here, okay? So that's why I prepare already this grid, nicely sketching, scale it. Now, first I noticed that this is a little bit of twisting order. So I'm going to change it in the easier way. I can see it, the transformation, right? Y will be equal to F. Now this is minus X. So I'm going to put the minus outside. I'm going to put the X like that. So if you multiply in, it's negative X anyway, right? This is positive, but because I factor out the negative, so I'm going to twist this sign, negative become positive. In that way, I'm not confused about the value, right? Negative multiplied with positive is still negative. Actually, this is positive, so this should be negative. So that this is negative, and negative will become positive 1 like that, right? So even though I twist their position, but the value is not changed. This is minus X. Time this with this, we have positive 1, right? And why do I twist it in this position? Now, for convenience, we know this kind of transformation it is, right? So this is the negative in front of the bracket like this. After the F function, this is a reflection over the y-axis, right? And this one is shift what? Shift to the left or to the right? Now it reverses with the notation, right? If it's negative, it's shift to the right. If it is positive, it's shift to the left. So you know this is shift to the right. So let's do the right thing, right? So you see that how important of interpreting these little details correctly. If you don't remember do we shift left or shift right, we're in trouble when we see the sign like that. So the signs in math is so important, right? Okay, so now let's do the function. Okay, so now let's talk about in the order. Here we have the order of reflection over the y-axis and the shift. Which one we should do first? Do we shift first and we reflect, or do we reflect and we shift? That is important now. So my hint to you, do the reflection first. Always do it, follow the order of the transformation. We call the order of transformation. The order of transformation, you have to do reflection first and stretching first, if you have, right? If you don't have it, then of course you do the shift. But the shift left or right is always do after you stretch the vertical or horizontal factor or reflect it. So let's do the reflection first, right? And yes, the order affects the image. If you're not doing it in the order, you produce the wrong image. And that's why. Okay. So now let's do reflection over the y-axis. So we're still using the original graph here, right? Except we perform down here. Okay. So reflection over the axis, which is we're talking about this one. So we already know what is reflection over the axis mean, right? So let's put the coordinate, okay? So we want to do reflection over the y-axis. Reflection over reflection over the y-axis. Over y-axis. So which graph we're going to base on? Now this is the original, but we already did reflection over the y-axis, except that this is, we do both. So actually we cannot use either of this graph because both of this graph is the reflection over the axis. But here we do over the y only, we don't have the x, right? So we have to reduce a new graph. So how do we do that? The reflection over the y-axis based on the original. So if we reflect over the y-axis, the x-coordinate will change. So 1 here, positive, will become 1 here. So positive 1 will become, a positive x, right, reflect over the y, positive x will become a negative x. So instead of the point here, it will be here, right? The base point is 2, stay the same. So this point stay the same, right? Because the x will be, what I'm talking about, I'm sorry. Yeah, the x, okay, so the x is 2. So x is 2 right here will reflect over the y-axis. So positive 1 become negative 1, positive 2, right? Positive 2 will become negative 2. So we give us this point. Okay, now another thing you can do, you can try like this. If this point is 1 and 1, when you reflect over the y-axis, the x will change, so that will become -1. The y stay the same, 1. Another point here is 2 and 1. When you reflect over the y-axis, the x will change is -2 and 1. So -2 and 1. What else do we need? The 2 here is the y, the 0 is the x. So it doesn't change. This point doesn't change. This point here is 4 and 3. So 4, 3 we'll change it to minus 4 and 3. So 4 and 3 will change to minus 4, which is here, and 3 is here, so this point. Okay, so that's the point. Okay, so now we will draw this, right? So our first transformation look like this from the original function. So this is the reflection over the y-axis. That's right. So now what else do we do? After this, we have to shift to the right 1 unit. So shift to the right 1 unit is easy. This point will be shifted to here, right? And mark the X here. And this point will be shifted to here. This point will be shifted to here. 1 unit. And this point will shift to here as well. So this point shift to here. So our next sketching will be like this. When we shift to the right 1 unit. So let me erase the first one and just keep the full concept. This one to shift to this one. So it should look like this. Right? So every point on the wrap will move to the right 1 unit. So it turned out we will have the wrap look like this. And if you notice, this is I draw longer, right? Longer this side, but now longer this side. This is shorter this side, but now shorter on the left, right? So that is how you do the transformation. Now the next part, I'm going to perform to you this sketching, right? So look at this cubic function, right? This cubic function have a degree of 3, x to the power 3 minus. After we done this second sketch, I'm going to show you one more last sketching for this third original function here. So this is the polynomial function with the degree of 3. This is a function f of x, have a x to the power 3 minus 5x squared minus 12x plus 36. Now we want to sketch this transformation based on this notation. So the question asks us to sketch this function become this function. Now what does that tell? For the 2 here, it means the function will be stretched or compressed. Like I think icon is compressed, but okay, so let's say this is the compressed function. And now why do we know? And what is a compressed? Does it compress the x or compress the y? If it's inside the function notation like this is the letter B, right? You know this will be compress the x value and not the y value. And this compression is based on a factor of 1 over b, which is 1/2. So the x coordinate will compress this in halfway. Instead of large like this, it will small, right? For the x. This Plus 3 indicates this, the function f of x will move to left, will move to the left and not the right, because this is plus sign. If it is negative, it will move to the right, but if it's positive, we move to the left. Now, the order is important in this way. The order of transformation. Are we going to do the compress first, or are we going to do the moving first? Keep in mind that for this, you have to do the stretching factor first. So the stretching factor, instead of 2, it will reverse become 1 over 2, 1/2 for the b value, right? It's stretch. So I call this compress. Now people like to say stretch by factor 1/2. Basically by on mean the same like compress, right? Because stretch by a factor less than 1, so it will be 1/2. So the wrap will look compressed, right? Looks compressed, not stretching. So fx will move to the left, and the function will move to the left by 3 units. And which one we do first? We always do the compress first, right? So we're going to do compress. So do we compress the unit of x or y? If it is b value, we compress the unit of x. So minus x3 here, right? These are the unit of x, and the root of the function. This base point here is the root of function. As long as we get the wrap based on the root of this function, then it's fine. We can figure out the image of the wrap, right? So minus 3 will become, it's stretched by half. So the minus 3 will divide by half, will become minus 1.5. So this point will become this point right here, minus 1.5. The 2 will become a 1, so this become a point like that. The 6 will become the 3. So these 3 points, 1, 2, 3, will become 1, 2, 3 down here. Now keep in mind, this is just the first transformation, right? We'll do the second as well. And the y-axis, there's no effect for the y, because the y-intercept at 36 still stay at 36. So that is the y-intercept. There's no effect for the y. So we're going to compress the function by the value of x by 2, by half, sorry, and move to the right 3, move to the left 3 units. So minus 1.5 will move to the left, become minus 3. No. We move 3 units, right? So become 4.5 actually. 1, 2, 3, yeah. So become 4.5. So this, I'm going to cross it out because we're going to base on this, right? Now, the point here, the second point, will move to the left 3 units. 1, 2, 3. So 1 will become 2. We'll cross this out. And the 3 will move to 0. So I'm going to drop this out. So this is the point of our wrap, of new wrap look like. So this is the root of function. The shape doesn't change except it will look, instead of stretch large like this, it will narrower, right? So let's see how it look narrower. So this still, okay, so the 3 here will move. And this point, the y doesn't affect, but the x will affect, right? So it will move to the left 3 unit as well. So 1, 2, and 3. So our point is here. So the wraps will look like the root of the function. So this is how the wrap will look like. And you can see, obviously, we can see instead of stretching lot like that, it's narrower, right? Narrow by 1/2 unit, 1/2 factor, sorry, and it moved to the left 3 unit. So this is how the wrap look like. So this is the last draft. This the way how do I sketch this using this 3 base point clearly shown you in my lesson today. I hope you enjoy my video, and if you register to my online course, I have on the material written down to you the way we write out the notation of the function notations, what is the factor, vertical stretch factor A, what is the horizontal stretch factor B, what order we do first in the transformation. So I just show you how to sketch using reflection today, compress factor of the x-coordinate and reflection over the y-axis and over the x-axis. So these are very much basic information to give it out to you. Now I believe, even though if I was assume I was teaching in the classroom, we only have time to give you this much of the lesson time before we have to move on to a lot of stuff, right? So I try my best to give you more and more information in here and in my course online as well. But also I will have to follow the core of the curriculum. So I think at least I give you the idea how we transfer the points, how we sketch them, and the practice will come with you on your own when you register into my course online. So I hope that you enjoyed my video, and the detailed information I show you here on YouTube, as well as in my online course. Give me the thumb if you like my video to encourage me, and stay tuned for the next topic. Have a good day, everyone. Bye for now, and see you soon in the next video.